Welcome to Robots That Feel, Learn, and Dream, a special episode exploring 29 cutting-edge robotics breakthroughs submitted on June 23, 2025. Discover how advances in sensing, learning, and interaction are moving robots beyond factories and into everyday life. In this episode, you will gain insight into the evolving landscape of robotics and its real-world impact. Key themes shaping the field will be highlighted, including deep dives into transformative studies and future directions. Learn how new methodologies are making robots smarter, more adaptable, and increasingly human-aware. Robotics is a multidisciplinary field where mechanical, electrical, and computer engineering converge. Artificial intelligence infuses these machines with adaptability and intelligence, enabling perception, planning, control, and seamless interaction. Today's robots are not just tools, they serve as partners in homes, hospitals, warehouses, and beyond, reflecting the integration of advanced algorithms with physical action. The first major research theme is multimodal perception and sensor fusion. Robots now combine data from cameras, LiDAR, radar, and tactile sensors, greatly enhancing their environmental awareness. The PG-LIO system, developed by Joe and colleagues, fuses LiDAR and camera inputs for robust odometry. Wang and collaborators demonstrated radar event fusion, enabling ego motion estimation in harsh conditions. These sensor fusion strategies significantly improve reliability, especially in cluttered or low-light environments. Efficient learning and imitation represent the next central theme. Modern robots learn from high-quality, carefully curated demonstrations. The CUPID approach, proposed by Agia and colleagues, applies influence functions to filter training data, improving learning outcomes. Chen's SViP system sequences complex bimanual robotic tasks, while Li's DefFusionNet enables manipulation of soft objects through goal diversity. These innovations collectively advance efficient, robust skill acquisition in robotics. Human-robot touch and emotional interaction comprise a pivotal research area. Robots are increasingly capable of sensing and expressing emotions via haptic feedback. Ren and colleagues established that the context in which robotic touch occurs shapes human perception. Developments in electronic skin technology enable gesture recognition and emotional state detection. Such effective robotics open new possibilities for building trust and empathy within human-robot teams. Advances in navigation, planning, and safety are crucial for real-world deployment. Robots are being developed to navigate cluttered, dark, or dynamic environments. Sharma's Nova system implements object-centric navigation planning, and Li's Grand Slam enables large-scale multi-agent mapping. Emphasis is placed on safety, explainability, and human-centric design, ensuring robots operate effectively and responsibly alongside humans. Key findings from this collection of papers include several transformative insights. Ren and colleagues demonstrated that haptic perception is influenced by emotional context. Agia's work showed that curated demonstrations accelerate and strengthen robot learning. Chi's unified world models enable safe, imaginative planning, while sensor fusion techniques improve robotic robustness in extreme settings. Together, these findings represent significant steps forward in the field. Core methodologies powering these advances include deep learning, where neural networks drive perception and control, and sensor fusion, which combines diverse data streams for richer environmental understanding. Imitation and reinforcement learning facilitate efficient skill acquisition. Probabilistic and geometric planning approaches are used for manipulation tasks. Human-robot interaction design is evolving to support social integration, balancing technical sophistication with natural, real-time responsiveness. Featured in this spotlight is Situated Haptic Interaction, exploring the role of context in effective perception of robotic touch, by Ren and colleagues. This research illustrates that emotional context dramatically alters how humans perceive robotic touch, demonstrating the necessity for context-aware effective robotics. Its impact is profound, particularly in fostering human-robot trust and empathy. Another spotlighted paper is CUPID, Curating Data Your Robot Loves with Influence Functions by Agia and team. This work introduces influence functions as a means to select optimal training examples, achieving state-of-the-art performance with significantly less data. This paradigm-shifting approach advances data efficiency, making robot learning more robust and scalable. A third highlight is MIND, Unified Visual Imagination and Control via Hierarchical World Models by Kai and collaborators. This framework merges video prediction with real-time action, allowing robots to simulate possible outcomes and choose the safest, most effective path. MIND bridges the gap between imagination and real-world control, marking a significant advancement in unified planning and execution. Looking forward, the robotics field is poised for several promising developments. Anticipated directions include creating more robust and generalizable robots for diverse environments, advancing data-efficient learning through curated or self-selected examples, and enhancing emotional and social intelligence for natural human interaction. Unified planning, simulation, and real-time action will further integrate safety, transparency, and collaboration at the core of robotic systems. This synthesis was generated using OpenAI GPT 4.1, with TTS narration provided by Google and visuals created via Grok. All content received thorough review by a human expert, though minor oversights may remain. Comprehensive references for all discussed papers are included for further exploration. You have been listening to AI Frontiers. Subscribe to our YouTube channel to stay updated with the latest research presentations in robotics and artificial intelligence. Thank you for joining us on this exploration. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, complex research is simplified so you can stay ahead. Whether you are a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.